I would like to talk about the states of matter and the transitions between them. So there are three uh, common states of matter. Those are solid, liquid, and gas. Oftentimes they will be denoted with just S for solid, L for liquid, and G for gas. If you see these in a chemical equation, they're just denoting the state of matter that that compound is in. Now, but what do these things mean? Well, it has to do with the packing of the molecules that are in the compound and the amount of energy that they have. So let's look at the solid. Now, if we let these little circles represent atoms, in a solid, the atoms are neatly arranged, or well, the atoms are arranged not necessarily neatly, but they're packed together in such a way that if you were to leave them in some container, they would remain together. Now let's talk about liquids. Liquids are one of the two states of matter that are generally associated with being a fluid. That just means that it can fill the shape of any container that's in. It can flow. So in a liquid, we would have the molecules and they would spread out. They would fill the bottom of this container. And you've seen liquids before, such as water, gasoline, juice, milk, pop. They're quite common. Now, something that you don't see very often, but you need to live, is gases. You can think about air. Air has oxygen, which is required for life, but you don't really see them. But they are also a state of matter. And in the gaseous state, so if this is like a closed box, the gas molecules will spread around and they'll be moving around all over. So a gas will fill a container. Now you may be wondering, why would a different molecule be in any of these states of matter? And it has to do with the energy that is in that molecule. So as you have two molecules, if they have enough energy to be bound, they will be in the solid state. But let's say we pump more energy in. So let's put energy in here. What's going to happen? Well, they're going to vibrate. I'm just going to do these like wave lines to kind of show. So kind of think if you have two, I don't know if you ever played the game Blongo Ball, but the concept is there's two tennis balls tied to a string and you throw them and try to wrap them around poles. But if you took those two tennis balls tied to a string, you can think of those as the two atoms and the bond between them. Now what happens if you add some energy in there? Well, the two tennis balls will start shaking around and eventually they might start going back and forth, and in that case it might start loosening up, and then that would involve it going to the liquid state. In the liquid state, there's enough energy that the bonds are, you can kind of think of them as being more malleable in that the atoms can move around more freely throughout the compound, and it goes to form a liquid where they're flowing around, so they're not tightly bound together. That's due to energy. In order to break a chemical bond, you must add energy to the system. And then let's add more energy. Well, eventually, if you think back to the tennis balls on a string, you know, we're adding energy, they're moving around, and eventually that string might just snap, and then those tennis balls would be free to fly around. And that's would be the gaseous state. So in that state, the molecules are very loosely associated, and they just flow around freely, and that's why they fill up the container that they're in. So I'm just going to go ahead and erase this here. Because now let's talk about the phase transitions and what they're called. We won't go too far into what's happening on the chemical level, on the molecular level here. But it's very good to just know generally what these different transitions are called. So if we go from the solid to liquid, that's melting, and the opposite process of that is freezing. That's going from a liquid to a solid. These we see all the time. You can think of if you're making ice, you know, you can freeze it, you can melt it, pretty easy to do. And you've probably had a lot of experience with this. Then we have vaporizing and condensing. That's when you go from a liquid to a gas, or from a gas to a liquid. And then stuff that's a little less common in everyday experience, but is still important to know, is if you go from a solid directly to the gas without entering the liquid phase, that's called sublimation. And the opposite of that is called deposition, or it's depositing. So you can see these red little stars here. Now what do those mean? In these reactions or in the processes marked with the red stars, those are the processes in which energy is being released. So as I mentioned earlier, and I kind of alluded to, whenever you break a chemical bond, it requires an input of energy with enough energy that is equal to the energy of the bond. But the opposite is also true. So when you form a bond, it will release energy. Let's see. So the phase transitions are, I think that might be a good place to stop for them. They're not too horribly difficult at this stage, as I think you have a lot of experience with them already. Just make sure that you know the names, and make sure you know in which processes it requires energy, and in which processes it releases energy. And those are the ones with the red stars, are the ones that release energy. I'll be happy to answer any questions in the comments, and I hope that this video has been helpful. Have a good day.